Alrighty, what's up everyone? It is Stefan here, and I hope you guys are having a fantastic day so far. Welcome to my first ever educational video that I am posting. I'm sure for my channel you guys have seen that I've posted a lot of gaming type content, but today I've decided to make a unit circle video because I've just finished calculus at school, and in calculus we do talk about the trigonometric identities, and another one of those components is indeed the unit circle. So it is fundamental that we memorize the unit circle to some extent, and that's why I'm here today, because from my experience it is not that easy to memorize the unit circle, right? We try to come up with a plan like, oh, okay, so one part of the circle is going to be 5 pi over 6 and the other is 11 pi over 6, and how do I know which part of the circle is which, right? It can get really confusing really quickly. So the goal of this video is to come up with a more intuitive and more logical way of memorizing the unit circle, because for me, I'm not good at memorization, right? I don't like memorizing things. So I think the best way to remember something is to come up with a logical way to think of it, right? So we can first come up with a little depiction of what the unit circle will look like. So what I want to start with is understanding where the points are, okay? I want to start off by saying that it is best to draw these 4 quadrants first, okay, in a unit circle. If we do not know already, which is okay, we know that the unit circle starts from 0 and it goes in the counterclockwise position. So it goes around this way, right? And I'll just draw it to this extent and just continue it on the other side. And we know it goes around the counterclockwise direction. So if we know that this goes around the counterclockwise direction, we know that we start from this point right here. In this black mark, it is known as simply 0. So let's add in a 0 at this point. We just put a 0. Really simple, right? 0. Now, if we are looking to go in the counterclockwise position, we also need to know that opposite from 0 is going to be pi, right? We first need to remember that, and I'll write this down here as notes. So this is the first important thing to remember, is that a full circle starting from 0 all the way around one time, it is known as 2 pi. So if we go around the whole circle, and this is known as 2 pi, we can also write 2 pi on the bottom here. So let me just write 2 pi. I can also add in the symbol for pi, but I'll just write 2 pi for now. So if we know if we go around the entire circle once, it's also known as 2 pi radians, and I'll put this here. We know that one complete revolution around the unit circle is known as 2 pi radians, okay? So with this in mind, if we start from 0 and we go to halfway, a track that is 2 kilometers long, and we run half of it, well, that's just 1 kilometer. So then this just becomes pi. Now we have this point starting from 0 and we run all the way around the track, and this is 1 pi or pi. At this point, we have noticed how one complete revolution is known as 2 pi radians. If we divide 1 pi by 2, we get 1/2 pi. And here's one thing to note at this point. And what is important to understand when we talk about 1/2 pi is that a lot of people, and this is what most mathematics papers or even textbooks, a lot of people like to write pi over 2. So these mean the same thing, right? But one is easier to understand than the other, because when we see later that this point right here is known as 3 pi over 2, it gets a little confusing for some people to remember. Why is this 3 pi over 2, right? And I'll show you why this method is easier to remember. 3 over 2 pi, it's the same thing as saying 3 pi over 2. But what's the difference here? Well, we know that 3 over 2 pi is the same as saying 1 and 1/2 pi. Now, does that make a difference, right? Now that visualization, it helps us to understand why this is 3 pi over 2. People write 3 pi over 2 is the same thing as saying 3 over 2 pi or 1.5 pi. And we know that pi is over here. We started from 0 and we've gone to 1 and we've gone another half, right? So we have gone 3/4 around. And that makes sense, doesn't it? But people just read it 3 pi over 2 for simplicity's sake, as well as just the mathematical correctness, so to speak. And then we finally complete our revolution. We can just use this 2 pi. But what 2 pi actually means, which should be obvious at this point, is actually 4 pi over 2, right? And 4 pi over 2 just means 2 pi because 4 divided by 2 is 2, and therefore this is 2 pi. Now, this is known as quadrant 1. We start off here, right? And I would encourage you guys to pause the video to just think of where quadrant 2, 3, and 4 are. And keeping in mind that we're going in a counterclockwise motion. Well, it should be logical that quadrant 2 is going to be here, because we're starting off with quadrant 1, and then we're moving along the circle all the way to quadrant 2. We have covered this part now, and then we move on to quadrant 3, and finally quadrant 4. There's also another reason why it is good to remember. It's because there's another rule. There's an acronym that is important to remember, and that is all students take calculus. Okay? And while this might not always be true, the acronym helps us to remember which quadrants, right? Which quadrants have the different trigonometric identities, and which ones are positive and which ones are negative, right? Just think of it as going from quadrant 1. So I'll just put this after A, I'll just put Q1. So this is quadrant 1, quadrant 2. In T, this will be quadrant 3. And finally, C will be quadrant 4. Well, we can think of this as there's always going to be sine, cosine, and tangent, right? Those are the 3 trigonometric identities. Everything else, cosecant, secant, everything else can be arrived at using the simple cosine, sine, and tangent. So in quadrant 1, we start off with A, an acronym ASTC. So we know that all, which means sine, cosine, and tangent are all positive. In quadrant 2 now, sine is positive. In quadrant 3, we move on to T, which is take. So if we have take, then take, this tells us that tangent is positive. And finally, last but not least, we have the 4th quadrant. And the 4th quadrant, the only one left is calculus, which is cosine is positive. So we just have to remember these 4, right? The acronym spells out ASTC, or all students take calculus. So if we remember this, and we know that we start from quadrant 1, and we move on to quadrant 2, 3, and then 4, we know that in quadrant 1, all sine, cosine, and tangent are positive. In quadrant 2, we know that sine is positive. Quadrant 3, we know that tangent is positive. And finally, cosine is positive in quadrant 4. And now we start splitting up the circle. And instead of splitting it up in a very disorganized manner, I'll start off with this method, as this one is the most effective method. This circle is not drawn to scale, but I'm just trying to make sure that the origin is at 0, 0. And this is same, the radius is 1. We're looking at this circle, okay? And we just want to focus on this part. Let me just draw so then you know what I'm mentioning. So we just want to start with this part right here. This part right here first. we know that this is, and actually I'll just use my method so then you can more easily see why this method is more helpful. So this point is actually 1 over 4 pi. What is this? Right, this point right here, what is this point? How do we know what this point is? Well, we know what this point is because instead of looking at the entire circle, we know that if we go to this point, we are moving 1/4 of 1 pi. 1/4 of 1 pi, okay? Which means that we have moved 25% towards this entire semicircle, okay? So I'll highlight this actually because I think it is important. If we move here, we have covered 1/4 pi. And then next, if we move to this point, right, we have covered this point, we've covered half, or pi over 2, right? If we cover another quarter, all right, because each one of these is 1/4. You can think of it as this whole point right here. This point is 1/4. We have moved this 1/4 times 2 because we have moved twice in this same cut, right? Slice of the pizza. Then we have moved 1/4 times 2. And if you take 1/4 times 2, it is just simply 2 over 4, which is 1/2, which is specifically what we have. And now if we take the time and we move another 1/4 over here, we already have 2 quarters, right? We know that 1/2 is also, you can think of it as 2 over 4. So if we move another 1/4, 2 over 4 plus 1 over 4 is 3 over 4, which also tells us that this is just simply 3 over 4 pi. If we complete our half a revolution and we move towards this point here, we're simply just adding another quarter. So if we have 3 quarters and we add another quarter, what does that give us? 1, right? That gives us 1. And 1 is simply 1 pi. So you can see how my method of thinking, instead of thinking, oh, 3/4 pi, it might be difficult to remember that. Simply think of it as taking simple chunks, right? 1/4 pi, you move another 1/4, becomes 1/2, or 2 quarters. You move another 1/4, it's 3 over 4 pi. This is the same as saying 3 pi over 4. This is the standard notation that you'll find, or the standard way of presenting this this angle theta around the circle, right? Theta in radians is 3 pi over 4. You can think of it as taking simply the numbers and then multiplying it by pi. In this case, it is 3 pi over 4, or 3 pi over 4, or 3/4 pi. So this is the same thing for the bottom, right? We can think of this as 4 over 4 pi. If you write it this way, then we know we can better conceptualize why this part is actually 5 over 4 pi, right? It's easier to see now. Why is it 5 over 4 pi? And, textbooks will write it once again as 5 pi over 4. But we now know, it's obvious to us why it's 5 over 4 pi. Because we have started from 0 over 4 pi, 1 over 4 pi, 2 over 4 pi, or 1/2 pi, 3 over 4 pi, 4 over 4 pi, and now we have moved on to another, and it's just 5 over 4 pi. And then we continue our journey around the track. This one, 5 over 4 pi, this will be 6 over 4 pi, and 6 over 4 pi can be simplified into 3 over 2 by dividing the top and the bottom by 2. This is 7 over 4 pi. 7 over 4 pi, right? And this is the correct value. This is 7 over 4 pi. Okay? And then if we move one more, it's 8 over 4 pi. 8 divided by 4, it is 2. And we arrive back at 2 pi. So you can see that this method of just thinking of it as whole fractions, just fractions, and then multiplying it by pi, instead of thinking a number multiplied by pi divided by a whole number in the denominator, it's easier to conceptualize and easier to remember why these numbers take up the spots where they do. And this works for the rest of the circles too, and it is important to understand y. The denominators for these parts, these denominators are all the same, right? You have over 4, you have 1/4, you have 3/4, you have 5/4, and you have 7/4. It is not coincidence, right? It is because we're adding specific parts. It may not seem this way in the beginning, but now that you've been exposed to this new way of thinking of the unit circle, it will be clearer why. It will just be a little messy, more difficult to see, just because we'll have more and more lines. We actually have 2 more sets of lines that we'll be drawing, but I'll try my best to make it as intuitive and as visual as possible without confusing everyone. So I'll make these the weight of these lines heavier. Now we move on to we can start either dividing the circle into halves like this again, right? We can either do this, or we can also divide it here. It doesn't really matter which part you divide it by. You just need to understand why they're divided, like the values that they share. So I'll just color code this into a different color. Let me just put green. And if we and I'll also touch upon another important thing to remember, which is this, right? Before we had these 2 green lines, we just had this, which is easy to think, right? Because we're just dividing it into halves. But a potential mistake that people make, they tend to do this. Okay, so let's say we divide this over here like that. And let me color code it so then you know what I'm talking about. They divide the circle like in this fashion, which is totally is completely fine. And then what do they do next? They divide it like this. Now what's the issue here? Right? Later on, when we find out the values for these points over here, right? The ones at the ends of the green line, and we just simply plug them in, they won't make sense because they're not symmetrical on both sides. This placement of the line here and this placement of the line here, when we are writing it on a piece of paper, it becomes very difficult to see where the values go if we do not care about where we place these lines. It is important that when we are drawing these lines, that we look at where the ends go. If we start off with this green line, right? We start off with this green line, and we have decided to split the circle in halves between pi over 2 and 1/4 pi, then we need to also make sure that when we are making the other split, that we are doing it on the opposite side. So think of this middle line or half pi splitting, reflecting whatever is being split on the opposite side. So if it splits here, we want to make sure that it's done on the opposite side, it's split in the same manner. And for the bottom as well, if it's split here, we want to make sure that it's split on the opposite section as well. So with this covered, these 2 new points, it is important to conceptually understand why this point is pi over 3. Now, as we have said before, right, we're taking a circle and we're dividing it into many different segments, okay? And this wasn't here before, but we have just added this in because we need to know what this point is. Okay, this part right here is 1 over 8. And we're adding 1/4 here, right? Because we just found out that this part over here is actually 1 over 8. This part right here. So we take 1 over 8 plus 1/4 equals 1/4 pi. And this is the same as saying if we make sure that the denominators are the same, then this is just 1/8 plus 2/8, because if you multiply by 2 here, we multiply by 2 here, right? We have 2 and the bottom is 8. So this is the same as 2 over 8 plus 1 over 8, so this is 3 over 8 pi, right? And we're like, oh my goodness, we have actually found a point is 3 over 8 pi, right? But what's funny about this is that it actually isn't 3 over 8 pi, right? As we said before, it is actually pi divided by 3. Okay, and at this point you're like, oh my goodness, I'm freaking out, or I don't know why this is not 3 over 8 pi. And in order to find out what this point is, we have to kind of conceptualize, visualize a little bit, and just remember that this is actually, this diagram is not to scale. And what this point is, and I'll write it in my notation, is actually 1 over 3 pi, or 1/3 pi. Okay, this is the same as saying 1, it's just like pi over 3. We can think of this first part right here, and remember that this is just not to scale, I'm just showing this conceptually. This is 1/3 pi. This part right here is another 1/3 pi. This part right here is another 1/3 pi. So then if you have 1/3 pi, 1/3 pi, 1/3 pi, then it's just 1/3 plus 1/3 plus 1/3, or 3/3 pi, or we arrive back at our original 1 pi. If we have ran 1/3 of half the track, right? Half the track here, we have ran 1/3, we have reached this point, right? So this is 1/3. And then we continue on, this is another 1/3. And then we finish off, and this is our 1 pi, and now we are halfway around the race. But so far we have only covered this point here, which is simply 1/3 pi. Okay? So if we covered 1/3 pi, what is this point? Well, if we covered 1/3 here, then we know that since we're separating this into thirds, we've covered 1/3 here, then we've gone 2/3, and then 3/3 or 1. So this is simply just 2/3 pi. So this is 2/3 pi, or what textbooks write 2 pi over 3. Right? 2 pi over 3 might be more difficult to see because it's like, what is 2 pi? Right? 2 pi, right, is this entire circle divided by 3. Hold up, how does that even work? How do I even think about that? Are you saying that you want me to divide this entire circle, and this is what we'll think immediately, into this? So then we have one part here, we have a second part over here, and then finally we have a part over here. Do you want me to think of it like this? Well, mathematically this is correct, right? This is correct, but it is just difficult for just with our human sense perception in terms of like sight to even think about that way, right? So this is why if we think about it in our terms, right, we're going 1/3 here, 1/3 pi, and then we're going another 1/3 pi here, and then finally we finish it off with another 1/3 pi here. This is easier to see because we simply just add up the 1/3 from 0 to 1/3 pi, and then move on to 2/3 pi because we're adding 1/3 to 1/3, and then we finish it off with another 1/3. Now we have these points already, right? So how do we fill in these two other points? We know that this is 1/3 pi, this is another 1/3 pi added on from the original 1/3 pi, so then this gives us 2/3 pi, and this is just simply 3/3 pi. So we know that 3/3 pi, if we add another 1/3, that becomes 4/3 pi, and that's actually this value, 4/3 pi, right? 4/3 pi is this specific value over here, 4/3 pi, or 4 pi divided by 3. Now it gets kind of crazy if you think of 4 pi divided by 3, because that's saying that we're going around this entire circle. We're revolving twice, right? We're saying that we're starting here and we're revolving around 2 times, right? And we reach back here again. We're saying with this, we're cutting this into 3 parts. I can't even begin to think of how to cut this up, right? So by adding 1/3, 1/3, 1/3, that's easier, much easier for us to envision, right? And to better understand it logically. And now we know that we've covered 1/3 pi, 2/3, 3/3, 4/3. So then we add another third, it becomes 5/3. There we go, 5/3 pi. which is actually the correct value, I suppose. 5/3 pi here, right? And then now we move on, 6/3 pi, which is equal to 2 times pi, which is just our simple 2 pi, which is what we have originally, 2 pi. Now we need to know what this point is, right? We just have to remember that this is pi over 6. What you may start to think or start to understand is that the unit circle, it is not perfect, right? It is not perfect in a sense where I can simply take this point here, and I just divide it into 2, and then I can simply find what this point is, right? It is not that simple. It's not, the unit circle isn't friendly in that manner. Because if you do, then there will be 1/8 pi, which is actually not what pi over 6 is. So we have to just remember that this circle isn't friendly in that manner. What's this value here? This is when we start to think of it in the way that we did before. This point over here is 1/6 pi. And then we move another, just pretend that this is equal. This is another 1/6. And then we move this point over here, and this is 3/6 pi, right? And this is halfway. And then we have 4/6 here, 5/6, and now we have arrived at our point. So we said 5/6, right? We have a separation here. This is 1/6 pi, and this is 2/6. Or let me just draw it. Maybe I'll draw it like this. And then this over here is 3/6, right? And then over here it is 4/6, and this over here is 5/6, right? And 5/6, right? We think we start here, and then we move on, and then we hit 5/6. So this point over here is simply 5/6 pi. You can see it becomes more increasingly challenging to even understand why 5 pi over 6, just to imagine it, is very challenging. We're saying that we have 5 of these 1 pi's, so we're moving 5 times around, which means it's actually 2.5 times. So because this would be 1 pi, 2 pi, 3, 4, 5, so it's 2.5 revolutions, and we're dividing it into 6 equal parts. Like, how would you even think of that? You can't. But this way is much easier at this point, since we're just reflecting it over. All right, we can think of, as I said before, this middle line, right, the pi over 2, as well as the pi, this is just reflecting over. So now this is 6/6, right? We have this point over here, and this point over here is indeed 7/6 pi. 7/6 pi, or textbook notation, I guess you can say it, is just 7 pi over 6, right? So 7 pi over 6, 7 over 6. At this point, you don't even have to go through the entire thing, right? If we know that this is 1/6, we moved up 1. So then over here, we know that we're actually just subtracting 1/6, right? If we're just subtracting 1/6 from 2. So if we have 2 minus 1/6, right? Because these 2 points are the same, and these 2 points, you can think they're basically the same cuts, right? All the cuts are the same for the 1/6 pi. Then with this, we know that 2 minus 1/6 is basically, we want to make sure that the denominators are the same. This is actually 2 over 1. Then this is just simply 12 over 6 minus 1 over 6. So 12 over 6 minus 1 over 6, it is 11 over 6, which is your final point on the circle. This is just 11 over 6 pi, or 11 pi over 6. So that's how you remember it. This copy of the unit circle is just copied from the bottom, but I just decided to use this part, a new little page, so then it's clearer, it's more organized. Now, for every single point here, right, for every single value in radians, we need to find, in order to find, for example, what is the cosine of 1/4 pi, or what is the sine of 5/6 pi, and so on and so forth, we need to know what the values are in coordinates. So one note to make before we even start. This is something important to note, because when we do have a value x and y in here, right, and we want to find a cosine or sine of something, you need to understand that whatever is in the x value is going to be cosine, and whatever is in the y value is going to be our sine. If we say 1/6 pi radians, it is basically saying that we're using this 1/6 of 1/2 of a revolution around the entire circle, right? You can think of it as basically, in other words, it's like a ratio. Well, this might be difficult for some of us to remember, and we might not know what 1 radian is. But remember how we said that 1 complete revolution, or 360 degrees, is equal to 2 pi radians? Well, 1 radian, or 1 pi radian, is simply half the circle. And half the circle, we should know it is 180 degrees. So if we have pi is equal to 180 degrees, then what we can do is simply taking that portion and multiplying it by 180 degrees. Then we're basically just saying 1/6 times pi, right? 1/6 times pi, because this 180 degrees is interchangeable with pi. So it's basically saying 1/6 times pi, which is basically 1/6 pi. So instead of saying 1/6 pi, we're just substituting pi with 180 degrees. So once we do that, we have 180 degrees divided by 6, and that's simply just 30, because 30 times 3 times 6 is 18, and you add the 0 behind is 180. So once we have this 30 degrees, what does this 30 degrees mean? And how do we convert 30 degrees into the coordinates x and y, or cosine and sine? Well, this is where our special triangles come in. And we can see here there's the 45, 45, 90, and there's the 30, 60, 90 triangles. Now, we know from this, and it should be apparent by now, that this 30 degrees is simply this 30 degrees, right? So how do we find cosine and sine, right? How do we find our x and y values? Well, we just use what we know from trigonometry, and so in order to find what the x value is, we need to evaluate the cosine of 30. Well, the cosine of 30 in this special triangle is simply the adjacent divided by the hypotenuse. Root 3 over 2 divided by 1. So root 3 over 2 divided by 1, anything over itself, and anything over 1, it's itself. So that is simply just root 3 over 2. So we have root 3 over 2. How do we find the y value? Well, the y, we know that is just simply sine, and sine is just opposite divided by the hypotenuse, which is just 1/2 divided by 1. Anything divided by 1 is itself 1/2. We have the coordinate root 3 over 2, 1/2 at 1/6 pi, or pi over 6 radians, right? So for example, if you see something on a test that says what is the sine of pi over 6, then you know that it is just 1/2. And if you find a question that says what is the cosine of pi over 6, then it's just root 3 over 2. Now, we can go on and we can just simply find all the values, just simply plug in 1/4, multiply it by 180 degrees, and then find out the degrees and look for a pattern, and do everything we did. But there's a simpler way, right? There's a simpler way. And the simpler way is just remembering these few values. And why do we have to remember these? Well, it actually it saves you a lot of time if you do remember these, okay? So think of it as a pattern, okay? We know, and this is the beauty of mathematics sometimes, is because we find patterns, right? Sometimes we do find patterns. The pattern is that for every middle value, it is always going to be root 2 over 2. The only thing we change is the sign. The sign that is in front, in the x or y. Okay, so for 1/4 pi, you just have to remember root 2 over 2. For 1/3 pi, it is 1/2 root 3 over 2. We can kind of see a pattern here, right? It's basically the x values flipped, and that's your y value. Those are your y values. So we have 1/2 root 2 over 2, root 3 over 2, and then we have root 3 over 2, root 2 over 2, 1/2. So it's just flipped, right? It's in that sense, it is easy to remember because there are only these three values. It's only these three values, and everything else stays the same, right? We still have our cosine, our sine, our cosine, our sine. So in any question, if there is a question that says, what is the cosine of pi over 3? Then it's just 1/2. What is the cosine of pi over 4? Root 2 over 2. When you are simply moving towards, I guess you could say, the negative side, right? The negative side of the unit circle, because remember the unit circle, this is the origin, this is -1, this is +1. So when we're moving towards the negative side, we can still use what we had on the positive side, but we just have to remember that we apply a negative in front of our x values. Same for this, we're applying a negative in front of our x values. These are the values, the coordinates for these 3 points. So in a question, if the question is asking, what is the cosine of 2 pi over 3? Well, it's just -1/2, right? What is the sine of 2 pi over 3? Well, that's just root 3 over 2. We know, and even, extrapolating this idea of simply a Cartesian plane, we know that in quadrant 3, right? We know that in the bottom left corner of any Cartesian plane, it is always negative, right? So we know that this first value is going to be negative as well as the second value. So the bottom values, we just flip the x and the y. So this would simply be root 3 over 2. And this would simply be 1 over 2. The x and y values here are negative, or cosine and sine values are negative. Then this is just negative root 2 over 2. And same as the sine value, root 2 over 2. So over here you can see it once again. This is -1/2, negative root 2 over 2. So then we know for this value, it is simply just going to be root 3 over 2. Negative root 3 over 2. And for our cosine value, we just have that -1/2. And we do it for this side as well, right? We can do it for this side as well, which is the fourth quadrant. I'll give you a minute. I'll give you a moment to think about which values come in, right? Think about how we simply flip the values here, right? We have the first value, we just simply flipped it. So what do we do for these values over here? So this would just simply be root 3 over 2, 1/2. Root 3 over 2, and 1/2. For this, once again, we just have root 2 over 2, root 2 over 2. And finally, we have our 1/2, and then we have our root 3 over 2. Now, let me ask a question. Are we complete? Have we completed the unit circle yet? If your answer was no, then you would be correct. Because, remember, we went down 1 unit, therefore, it will be a negative y value. And we know that y is x and y, so therefore we have -1/2, negative root 2 over 2, and negative root 3 over 2. And that is the final completed version of the unit circle. I hope that this video has helped you visualize, conceptualize, and also be able to use a little bit more logic into remembering the unit circle, it seems like it's a huge daunting task to remember every single one of these values. But by picking apart different parts of the unit circle, we can slowly start to see the simplicity behind the unit circle, right? And I hope this video has been of some help. If this video was of some help and you guys would like to see more videos in the future, please do comment down below. Like the video, share it with your friends and family. And it's been Stefan. Hope you guys enjoy. Thank you so much.